Hello students, so today we are going to see galvanometer and conversion of galvanometer into ammeter. Next topic will be conversion of galvanometer into voltmeter. Okay, so from last class onwards we are seeing instruments, electrical instruments. We have seen about meter bridge. Meter bridge is to measure a resistance, okay, to measure an unknown resistance. Okay, ammeter is to measure current, voltmeter is to measure voltage. So while doing electrical works, electrical experiments, we need to measure all these. So this is what we are seeing now. So what is galvanometer? Galvanometer is a device which will not measure current actually, which will detect the presence of current. It will detect the existence of current, small current, that also. Okay, so first point is galvanometer detects, okay, the presence of current. Okay, and it can detect only small amount of current. Small amount of current. Suppose if we pass high amount of current, galvanometer will get damaged. We have discussed about galvanometer while studying Wheatstone's bridge also. Okay, we have seen, suppose resistances connected like this, and in between, after connecting a resistance, here we had a galvanometer. We connect this to a battery also. So here, if R, S, P, Q, whenever current will be passing through this, when current passes through this galvanometer shows deflection. When R by S is equal to P by Q, when this balancing occurs, there will not be any current passing through this, so current through galvanometer will become zero in this condition. So this galvanometer, if current passes through the circuit, galvanometer will deflect. When we change the direction of current, galvanometer will deflect in the opposite direction. Okay, if we change the direction of current, galvanometer deflects in opposite direction. Okay, so if current is flowing like this, galvanometer, suppose if it is deflecting to this direction. Okay, suppose if we change the direction of current, if you are connecting battery in such a way that current is going like this, then the galvanometer deflection also will go to the opposite direction. Okay, these are few points. Now another point is suppose galvanometer will be like this. Okay, so here two side deflections are there. This will be just like a box. Okay, now suppose if we have 1 milliampere, 2 milliampere, maximum here 3 milliampere is here. Now suppose if we are passing 1 milliampere, okay, this will start showing like this. Now galvanometer will not measure current. Okay, this what I have written is for your understanding. it will show deflection. Suppose 1 milliampere, it has shown some deflection, it will come back. If we are passing 2 milliampere, it will show deflection like this, then it will come back. If we increase to 3 milliampere, it will show up to this, then it will come back. 4 milliampere current is passing, it will show up to this, then again it will come back. 5 milliampere, say for example, again it will show like this, it will come back. Now if I pass 1 ampere, galvanometer will show deflection like this, it will stop there, it will get damaged. Okay, so up to certain amount of current it will show deflection. Beyond a level, if we pass current, that is high amount of current means 1 ampere or 0.5 ampere, or that will be enough. Not 0.5 ampere, 5 ampere, then suppose if we pass 6 milliampere, it will get damaged. So 1 milliampere, 0.5 milliampere, 2 milliampere, this kind of very small amount of current only galvanometer can show deflection. So beyond that, it will show up to maximum deflection, again it will come back. But if we pass again still high amount of current, galvanometer will get damaged. Okay, then the construction of galvanometer, the coil inside it, the torque associated with this, all these things we will be studying in moving charges and magnetism, not in current electricity. There you will be studying about its detailed construction and its working. So here we are just seeing in the circuit level its need in finding the existence of current, conversion into ammeter and voltmeter. Okay, please note down these points. Okay, so a galvanometer, it consists of a coil. Okay, just a galvanometer coil. So suppose if we connect galvanometer in a circuit, current will be coming, so current will be passing through this, it will show deflection. Now there is an amount of current, it can show maximum deflection, which is called galvanometer current, which is a maximum current. Maximum current the galvanometer can handle. If we pass a current beyond this, it will get damaged. Okay, now our task is to measure reasonable amount of current. We need to measure 1 ampere, 2 ampere, 3 ampere, 5 ampere, all this amount of current we need to measure. So what can we do? Okay, so we will do some modification in galvanometer and we will use it as ammeter. Okay, that we will see now. So here we are going to study about ammeter. Okay, and in ammeter what we are studying is conversion of galvanometer into ammeter. So what is the features of ammeter? Why we are going for ammeter? It measures larger current. It measures larger current. It can be used to measure. Okay, so galvanometer cannot measure a large amount of currents. Okay, galvanometer cannot measure large currents. Okay, so what we do is we make modifications. We make modifications in galvanometer and convert into a meter. Okay, how it is done? Okay, we'll see. Okay, okay, so this is galvanometer. Okay, now what we do here is okay, so this current we need to measure. Maximum current this galvanometer can bear is Ig. Okay, so this could be a small amount of current. So what we do is, in order to reduce this current, if this full I passes through galvanometer, what will happen? Galvanometer will get damaged. So what we do is, parallelly we connect a small resistance called shunt resistance. This is called shunt resistance. Shunt resistance or shunting is nothing but connecting a resistance in parallel. Okay, why we are connecting in parallel? If we connect a resistance in parallel, this resistance, shunt resistance, will be of very small value. When this resistance is very small value, what will happen? Majority of current which is coming will be passing through this. If Ig is the maximum current a galvanometer can bear, then through this resistance all the remaining current, that is I minus Ig, will be passing through this resistance. So it will protect, on one side it will be protecting the galvanometer from getting damage. That is one advantage. Another thing is, just by taking the ratio of this, we can measure the large amount of current here also. I will show by giving you examples. So one side we have our galvanometer. So this galvanometer is having a resistance, that resistance be G. Suppose 1000 milliampere current is coming. 1000 milliampere current is coming. Suppose if this galvanometer can handle, maximum up to 10 milliampere. This can handle only up to maximum up to 10 milliampere. Then we will set this shunt resistance in such a way that 990 milliampere will be passing through this. Okay, so this shunt resistance we will do accordingly. We know current division rule. Suppose if galvanometer resistance is G ohm, this is galvanometer resistance. So galvanometer resistance is G ohm, and the current that is passing through galvanometer is 10 milliampere. And we know current division rule. We know the current division rule we have studied. So Ig is equal to this I into opposite branch resistance S divided by S plus G. So if we know this galvanometer current, maximum current, and how much current which we need to measure, how much current we are going to pass through this. If we know, then this resistance we can find out. We can find it out and we can place here. So same way, in order to have 10 milliampere current maximum through this, remaining all 990 milliampere to pass through this resistance, shunt resistance, we can place a shunt resistance there so that this will not damage galvanometer current. Now we do calibration. Calibration means actually this galvanometer should show, actually this entire setup is called ammeter. Actually this should show what? 1000 milliampere. See, why ammeter? Ammeter is to measure current. So when 1000 milliampere is passing through a circuit, when we connect ammeter there, it should show 1000 milliampere, not this 10 milliampere. So we can do calibration, means when 10 milliampere is passing through this, the needle here should show what? 1000 milliampere. So the writings here we will change accordingly. Suppose here it is 10 milliampere. Suppose 900 milliampere is passing. Then suppose if we are, this is galvanometer, this is shunt resistance. Suppose here 9 milliampere is passing through this. Okay, this is going to be 890 milliampere. This is 9 milliampere. So here this needle will be showing in this way. Here what will be written? 900 milliampere will be written. Here what will be written? Here 1000 milliampere is written. That is, we will calibrate this galvanometer in such a way that if the current passing through galvanometer is 10 milliampere, it will be showing 1000 milliampere. If the galvanometer current is 9 milliampere, it will be showing, that needle will be showing what? 900 milliampere. If 8 milliampere is flowing through galvanometer, then it will be showing 800 milliampere. So what we should do? We will be doing calibration. The writings we will change accordingly. So based on the ratio of current passing through this galvanometer, the needle will be showing accordingly. Okay, so that is not our headache, that they will do. Those who are people who are making this, they will take care of this. What we need to do? What we need to do is we need to find the current accordingly. We need to apply our circuit basics and we need to find the currents accordingly. So in order to find it, what we need to do? We need to remember this, that is, the galvanometer current is nothing but this current, the main current that is coming into this branch resistance by total branch resistance. If we do that, we will be getting galvanometer current, or simply we can say that the total current I, this current that is I, is proportional to Ig here. Okay, Ig and I, they are what? Directly proportional. So if more current comes here, more current will be going through this galvanometer. Obviously maximum limit is there, but if this current is less current will be passing through this. If this current is more current will be passing through this. Maximum limit will be there. We won't pass the current beyond the limit, okay, so that galvanometer will be damaged. But in order to reduce the damage and in order to measure maximum current, we have connected a shunt resistance also here. Suppose if this is galvanometer resistance, the maximum current which can pass through this galvanometer is Ig. The current that is coming in the circuit which we need to measure this current is I, and shunt resistance is S. The current that is passing through shunt will be I minus Ig. Okay, I minus Ig. So if this is the case, then one thing which we know is they are in parallel. G, S both are in parallel. The voltage across galvanometer resistance will be equal to the voltage across this shunt resistance. Correct? So we can write Vg is equal to Vs, or we can write Ig, the current that is passing through galvanometer, into its resistance is equal to I minus Ig into S. Okay, so just remember this. Okay, remaining things can be done. Just remember this. No need to by heart any formula. Just remember this. This voltage is equal to this voltage, but nothing else. Okay, this current will be Ig, this current will be I minus Ig. So Ig into G is I minus Ig into S. So this Ig can be considered as the maximum current which is passing through the galvanometer. Okay, maximum current which can be passed through galvanometer. See, when it was used as galvanometer, the current which can be measured was very less. Now we have connected a shunt resistance. Now the current range is increased. Current range has been increased, but still there is a limit. No, since we have converted into ammeter, it doesn't mean that we can send any amount of current. No, it is not like that. Previously it was possible to measure only maximum milliampere range. Now we will be measure up to ampere ranges. Okay, 5 ampere, 6 ampere, that is enough. This 5 ampere is very big amount of current. Okay, beyond that, if current comes to our home, there will be fuse wire that will be melted off also. Okay, so remember this. The voltage across this galvanometer is equal to the voltage across this shunt because they are connected in parallel. Ig into G is equal to I minus Ig into S. Ig is the maximum current that can be passed through the galvanometer. Clear? This is the concept. Okay, and remember, G is galvanometer resistance. G is galvanometer resistance, S is shunt resistance. Okay, which is very small value. Okay, so this entire setup is what is ammeter. Note down. Clear? So take this question. A galvanometer has a resistance of 50 ohm. Okay, a galvanometer has a resistance of 50 ohm, and its full scale deflection current is 50 microampere. Full scale deflection current means the maximum current the galvanometer can have, that is 50 microampere. Now what shunt resistance should be added so that the ammeter can have a range of 0 to 5 milliampere? Okay, so 5 milliampere current can be measured maximum. That is nothing but that current that is passing through the circuit. The current that can be passing through, that can be passed through this galvanometer is what is given as Ig, the maximum galvanometer current. Beyond that, if we pass, that coil will be damaged, which is of galvanometer. Okay, so but maximum current which can be measured in the ammeter, that is this galvanometer, shunt resistance, everything putting together is what is given as 0 to 5 milliampere. Okay, so G is given and Ig is given. What is the shunt resistance? This is what the question is. So suppose if this is the shunt resistance, if this is the galvanometer resistance, this is given as 50 ohm shunt, which we need to find out. Then if Ig is passing through this, then if this is I minus Ig will be passing through this. So according to the equation, Vs, Vg both are equal. Vs must be equal to Vg. So I minus Ig into S is equal to Ig into G. Okay. So maximum current which can be measured is 5 milliampere. So 5 into 10 raised to minus 3 minus Ig is given 50 microampere. So 50 into 10 raised to minus 6. Okay. Into S is equal to Ig. 50 into 10 raised to minus 6 microampere into G is given as 50. Okay, so if we solve this, we will be getting this answer. Okay, so 5 into 10 raised to minus 3 minus 50 into 10 raised to minus 6 into S is equal to 50 into 10 raised to minus 6 into 50. So in order to solve it easily, right hand side 50 into 10 raised to minus 6 is there. So I am going to take this outside. So 50 into 10 raised to minus 6, if I take outside, I will be getting 5 into 10 raised to minus 3 divided by 50 into 10 raised to minus 6 minus 1 into S is equal to 50 into 10 raised to minus 6 into 50. So this can be cancelled out. I will be getting, so we can solve this. 5 will be cancelled off. This is going to be 10 raised to minus 3. This is 10 raised to minus 5. This will go up. This will become 10 raised to 5 minus 1 into S is equal to 50. Clear? Just trying to make the calculation easier. So if it goes up, this will become 10 raised to 6. So 10 raised to 3. This is there. So how to solve this? This will become 10. This will become 100. 100 minus 1 is 99. So 99 into S is equal to 50. We will be getting S is equal to 50 by 99. So this is just like a 0.5. We can take almost like a 0.5. Just looking at the option, there is no answer near to 0.5. So directly we can mark option B. Okay, so this is the answer. Clear? Nothing. Just this is shunt resistance. This is galvanometer resistance. They are in parallel, equating the voltages. Vs is equal to Vg. I minus Ig into S is equal to Ig into G. Then substituting, just for making the calculation easier, one thing we have taken outside, cancelled with the right hand side, then we did a small approximation. So that is the answer. Take this question. A galvanometer having 50 divisions has a current sensitivity of 20 microampere per division. So 20 microampere per division means one division is like a 20 microampere. That is its meaning. It has a resistance of 20 ohm. Galvanometer resistance is 20 ohm. How will you convert into an ammeter having range 0 to 10 ampere? So this is the current which we need to measure. This will be the current that is passing through the circuit. This will be the maximum current. So find the resistance of ammeter also. So first we will start with the 50 divisions. Okay, galvanometer has got 50 divisions and sensitivity, current sensitivity is nothing but 20 microampere per division. 20 microampere per division. So Ig the maximum current that can be passed through galvanometer is nothing but 50 into 20 microampere. Okay, so what this is actually 10 into 10 raised to minus 6, we can write 10 raised to minus 3 ampere or 1 milliampere. So this is the current that can be passed through the galvanometer. So 50 divisions are there. 50 divisions are there means each division is 20 microampere. So 50 divisions means, suppose if it is like this, 50 divisions can be this side, 50 divisions can be this side also if it is a galvanometer, if two sides are there, or this can be in this form also. From here it is 50. So all depends on the calibration of galvanometer, but we need not worry about that. Whatever be the information we have got in the question, with that what we will understand, the maximum current the galvanometer can bear is 1 milliampere. So that is ready. Now suppose if this is galvanometer, this is shunt resistance, this is the current I, Ig, I minus Ig. So Ig into G is equal to I minus Ig into S. So shunt resistance we need to find. Okay, the question is like, how will you convert into an ammeter having range 0 to 10 ampere? So how will we convert? We will have to connect a shunt resistance. Okay, so we will find it. So Ig is 10 raised to minus 3 into G is this resistance. It has a resistance, galvanometer has a resistance of 20 ohm. This is equal to, this is maximum current which will be passing through the circuit, minus 10 raised to minus 3 is Ig into S. S we need to find. So S is equal to 10 raised to minus 3 into 20 divided by 10 minus 10 raised to minus 3. So how we will simplify this? 10 raised to minus 3 into 20 divided by 10 raised to minus 3 we will take outside. So this is like a 10 by 10 raised to minus 3 minus 1. This will be cancelled out. This is going to be 20 divided by, so this is 10 into 10 raised to 3 minus 1. So 20 divided by, this is going to be how much? This is going to be 10,000 and this is going to be 9999, or simply we can take it as 10,000 itself. No change, nothing is going to happen. So 20 by 10 raised to 4. So this is going to be 20 into 10 raised to minus 4 ohm. So such small value of resistance we will have to connect as shunt. So this is the shunt resistance. Clear? Now what is the resistance of the ammeter? So I am erasing this. Okay, what is the resistance of the ammeter? So resistance of ammeter is nothing but this whole system is ammeter. This whole system is ammeter. So resistance of ammeter is nothing but G into S by G plus S. This is the resistance of the ammeter. Okay, galvanometer and shunt resistance, they are connected in parallel. So what is the resistance of ammeter? G is 20. What is S actually? S is, this is actually 2 milli ohm. This is nothing but 2 milli ohm, correct? So 2 into 10 raised to minus 3 divided by 20 plus 2 into 10 raised to minus 3. So this is 40 into 10 raised to minus 3, 10 raised to minus 3 divided by, what will happen if we 20 plus 0.002. So this is not going to make any difference. So simply I can write this as 20 itself. Okay, so we will be getting 2 milli ohm as the resistance of a meter. Okay, even if we solve this, we will be getting 1.9998. Okay, resistance of a meter is 2 milli ohm, almost like a shunt resistance. So when you connect two resistances in parallel, the overall resistance, the equivalent resistance will be lesser than the least resistance. Lesser than the least resistance. This we have discussed when we discussed equivalent resistance topic. Okay, so this will be less than the least resistance. So shunt is 2 milli ohm, means resistance of ammeter is actually 1.9998, somewhere like this it will come. Okay, so take this note. Ammeter is always connected in series to measure current. See, current is running across a circuit. So if we connect an ammeter in series with the circuit, we can measure the current. Okay, so current will be passing through this like this. So ammeter we connect in series in order to measure the current. Okay, so how much current is flowing to this bulb? If we need to measure, connect it in series. Another point is resistance of an ideal ammeter should be 0. Resistance of an ideal ammeter should be 0. Why we are saying like this? Okay, just look at this circuit. Okay, resistance of an ideal ammeter should be 0. Why we are saying like this? Suppose if we connect, this is a bulb. So bulb is nothing but a resistance. Okay, say for example, this bulb resistance is 4 ohm. Suppose if this battery is 12 volt. So current I will be passing through this. So what is this value of this current? This I is equal to V by R. We can say 12 by 4. This is going to be 3 ampere. 3 ampere current will be passing through this. Now, second part is, suppose same 12 volt battery, 4 ohm resistance is there for the bulb also. Suppose when we connect an ammeter, see, whatever we connect in the circuit, whether even for these wires also, some small resistance will be there. Okay, but we are considering that are ideal wires. We don't consider their resistance while we learn in +1, +2 JE Neet level and all. Okay, even in the JE advanced level also, we don't consider resistance for this wire. Practically when we do engineering level studies, when we really do circuit design and all, we will find the resistance of a wire, and in order to model that, if this total resistance of this wire is just 1 ohm, then when we simulate that in computer, we need to see the result. Based on that only we can directly apply in the practical circuits. When we simulate that in the computer, we will put a 1 extra ohm here. 1 extra 1 ohm due to this wire we will connect in the circuit while we try to calculate. Okay, in the practical circuit, that 1 ohm is nothing but this wire's resistance. So in short, what I am telling is, whatever we connect in the circuit, there will be some resistance associated with that. So this ammeter will have some resistance. Suppose for example, this ammeter has 2 ohm resistance. Okay, so what will be current? I will be equal to V by R equivalent. This is going to be 12 by 4 plus 2, 6 ohm. This is going to be 2 ampere. So actually the correct current is 3 ampere. So when we connected ammeter, we got what? How much? 2 ampere. So there is error. There is error. The result which is shown by the ammeter is wrong. 1 ampere difference is there. So that is the reason, one reason for finding shunt resistance as very low value. When we connect the shunt resistance as very low value, what will happen? The overall resistance of ammeter will reduce. So suppose if this ammeter has a resistance of 0.01 ohm or 0.1 ohm, then the error will be less, no? Comparatively the error will be less. So that is the reason when we try to connect the shunt, we will try to connect the shunt as minimum as possible. Okay, and the ideal condition is resistance of ideal ammeter should be 0. That is the ideal condition, practically not possible. But ideally, what we are longing, what we wish, what our desire is to get an ammeter with a 0 ohm. Okay, so that there will not be any error. But small error, practically we will have to tolerate, just because there is nothing like a 0 resistance ammeter. So that is why we are putting like this. So ideally resistance of an ideal ammeter should be 0. So in many questions ammeter will be connected and they will be saying that an ideal ammeter is connected. So if it is ideal ammeter, we need not worry about anything. That is nothing but we are measuring current. That is the indication there. We need not do any change in the circuit. But if the ammeter is not ideal, if it is practical ammeter, then there will be a resistance associated with the ammeter. That also we will have to consider in the circuit. Okay children, so that's all about ammeter. Okay, so next device is nothing but voltmeter. Okay, so meter bridge was to measure resistance, ammeter is to measure current, galvanometer is just to detect the presence of current. So galvanometer we converted into ammeter and we got a current measuring device. Now the same galvanometer we can convert into voltmeter in order to measure voltage. Okay, or the voltage across 2 points or the potential difference across 2 points. So we connect the voltmeter across 2 points. One circuit will be going like this. We will be connecting the voltmeter across 2 points. So voltmeter is a device which measures potential difference. Okay, voltmeter is a device which measures potential difference across 2 points in a circuit. Suppose if this is a part of a circuit, okay, this is a big circuit, but we need to measure the voltage across this resistance. Suppose, see, this is a circuit, okay, many things are there, okay. Okay, this is a big circuit. Now suppose if we need to measure the voltage across this resistance, what we do? We will connect a voltmeter across these 2 points. So point A, point B. So we will be able to, if we connect voltmeter across these 2 points, we will be able to measure the voltage across this resistance. Suppose if we need to measure the voltage across this resistance, we will connect the voltage like this. Okay, so this is the use of voltmeter. We will be able to measure the potential difference across 2 points. Okay, clear? Okay, another point is voltmeter is always always, voltmeter is always connected parallel. Okay, voltmeter is always connected parallel to measure the potential difference. No other go, because potential difference is measured across 2 points, so we will have to connect it parallelly. Okay, clear? Students, we will see now the conversion of galvanometer into voltmeter. Suppose say this is a bulb. So bulb is nothing but a resistance for us, and suppose if we are connecting a galvanometer across a bulb. So when we connect galvanometer, you know we have a problem. There is a limitation in the amount of current that can be passed through galvanometer. Suppose the voltage across this bulb is this, voltage across galvanometer is this. So voltage across bulb will be equal to the voltage across galvanometer. This will be equal to the maximum current that is possible to pass through galvanometer into this galvanometer resistance. Suppose this galvanometer resistance is 10 ohm, and this Ig, if this is 1, okay, just let's put 3 milliamp. So what will happen? 3 into 10 raised to minus 3 into, so this is going to be 30 millivolt. So this need not be correct. Suppose if we connect like this, the real voltage that is to be passed through bulb, okay, so this will have a problem for us, because mainly this Ig, this is the problem. So in order to measure any amount of voltage, so here we will be able to measure very less amount of voltage only. Suppose if we need to measure enough voltage range, what we will have to do? We will have to connect a high resistance in series with this galvanometer. So if that is the case, then what is the voltage across this? This V is equal to Ig into G plus R. We will be able to measure high level of voltage also. Otherwise we won't be able to measure high level of voltage because of this weak point of maximum Ig possible. So voltage is equal to galvanometer current into galvanometer resistance into the series resistance. This is series resistance, high resistance value which is in series with the galvanometer. We will be able to measure voltage, enough voltage values. Clear? Okay, suppose this Ig is 10 milliampere, this is 10 ohm, this value is 990 ohm. The voltage will be what? 10 into 10 raised to minus 3 into 990 plus 10. So 10 into 10 raised to minus 3 into how much? 1000. So 1000. This, if we measure, this is going to be 10 volts. So we will be able to measure 10 volt also. Take this question. A galvanometer has a resistance of 50 ohm and its full scale deflection current is 10 milliampere. So galvanometer resistance is given 50 ohm and full scale deflection current, that is the current that is possible through galvanometer, is 10 milliampere. So what resistance should be connected in series with the galvanometer? okay, what resistance should be in series with the galvanometer, so that its voltage range can be 0 to 10 volt. So voltage range, if we take a maximum voltage range is 10 volt. So we know if this is a resistance, this is okay, this is a circuit, any circuit, this is galvanometer, this is the series resistance, Ig will be passing through this voltage we are going to measure. So that is going to be 10 volt maximum. Okay, so this V is equal to Ig into G plus R. This is what the formula for voltmeter. So this 10 is equal to Ig is how much? 10 milliamp. So 10 into 10 raised to minus 3 into G is given as 50 and this R which we need to find. Okay, so 50 plus R is equal to 10 by 10 into 10 raised to minus 3. 10 will be cancelled off, this will become 1000. So R is equal to 1000 minus 50, this is going to be 950 ohm. Okay, so answer is 950 ohm. Okay, basic question in voltmeter concept. Okay, so here what is the voltage of what is the resistance of voltmeter? What is the resistance of voltmeter? So voltmeter is this much. This is the voltmeter. So resistance of voltmeter is nothing but the galvanometer resistance plus the resistance that is connected in series. Galvanometer resistance is 50 ohm. Okay, and the resistance which we found is 950 ohm. This is going to be how much? 1000 ohm. This is not asked in the question, but I am just mentioning for your understanding. So the resistance across or the resistance of voltmeter is nothing but G plus R. In ammeter, the resistance of ammeter was G into S by G plus S. This is G plus R. Clear? No need to by heart any formula, just understand the concept. Okay, voltage across this will be equal to the voltage across this. In ammeter also, voltage across coil and the voltage across the shunt both will be equal. Take the next question. So here the scale of a galvanometer, is divided into 100 equal divisions. The galvanometer has a current sensitivity of 10 divisions per milliampere. Okay, so it has got 100 equal divisions. It has got a sensitivity of 10 divisions per milliampere. That is, for 1 milliampere 10 divisions will be covered. So how can you convert it into a voltmeter of sensitivity 1 volt per division? Okay, 1 volt per division. Resistance of galvanometer is 5 ohm. Okay, so G is given as 5 ohm. Okay, G is given as 5 ohm. So here 10 divisions 1 milliampere. So 1 division is nothing but 1 by 10 milliampere. 100 equal divisions, galvanometer scale is divided into 100 equal divisions. So 100 divisions means this is nothing but 1 by 10 into 100 milliampere. So this is the current sensitivity of the galvanometer. Now how can you convert it into a voltmeter of sensitivity 1 volt per divisions? So this is about galvanometer. This is about galvanometer. So 100 divisions are there means this is nothing but 10 milliampere. What is this actually? This is nothing but its maximum current when it is a galvanometer. Voltmeter, when we convert into voltmeter, what we are doing? Still 100 divisions are there, because this galvanometer we are converting into voltmeter. So we need to convert into a voltmeter of sensitivity 1 volt per division. So 100 division means this is nothing but 100 volt. So maximum voltage which can measure is nothing but 100 volt when we pass maximum galvanometer current through it. Okay, clear? Now Ig into R plus G is equal to the voltage which is going to measure. Okay, this much is the maximum voltage. So 10 into 10 raised to minus 3 ampere maximum current which can pass. Galvanometer resistance is how much? 5. Now the question is how can it be converted into voltmeter of sensitivity? So this series resistance is not given. So when we pass maximum current, maximum voltage which can measure is nothing but 100. Okay, so R plus 5 is equal to 100 by 10 into 10 raised to minus 3. So this is cancelled. R plus 5 is equal to how much? 10 into 10 raised to 3. So the resistance R is nothing but 10,000. Okay, 4 zeros minus 5, 9995 ohm. So such a high amount of resistance, a large amount of resistance which we need to connect in series, okay, in order to convert into a voltmeter of maximum 100 volt, okay, which can measure 100 volt. See the students, the resistance of ideal voltmeter must be infinite. The resistance of ideal voltmeter must be infinite. Why we are saying this? Okay, suppose if we have a bulb of 4 ohm, suppose if the current passing through this is 3 ampere, then the voltage drop across this bulb is nothing but I into resistance of bulb, which is nothing but 3 into 4, 12 volt. 12 volt. Suppose if this is a bulb, across that, in order to measure voltage, we connected a voltmeter. Okay, now 3 ampere current is flowing through this. Okay, 2.9 ampere is flowing through this. Because of this voltmeter, when it is just like a resistance connected in parallel, 0.1 ampere is flowing through this. Okay, suppose if this voltmeter is not there, then full 3 ampere will be flowing through this. But when we connected a voltmeter parallelly, what happens? 0.1 ampere is taken by this voltmeter. Now the voltage, now if we measure across the bulb, this is nothing but 2.9 into, what is this? This is 4 ohm into 4. 2.9 into 4, that is the voltage across the bulb now. Okay, so this is coming as 11.6 volt. See the difference. This is 12 volt, this is 11.6 volt. So 0.4 volt difference is there between this circuit and when we connect the voltmeter circuit. Suppose if we have infinite resistance for this voltage, which is practically not possible, but if we have infinite resistance, this current will not flow through this. Or if we increase this resistance of this voltmeter very high, and if we are able to make, instead of 0.1 ampere,
instead of 0.1 ampere, if we are able to make 0.01 ampere, then this voltage can be reduced. The difference between these voltage can be reduced drastically. Okay, so the voltage of ideal voltmeter must be infinite. Clear? So take this question. A moving coil galvanometer, when shunted with a resistance of 5 ohm, gives a full scale deflection of 250 milliampere, and when a resistance of 1050 is connected in series, it gives a full scale deflection for 25 volts. Find the resistance of galvanometer. So here in this question, we are converting galvanometer into ammeter, full scale deflection 250 milliampere, and we are converting this galvanometer into voltmeter with a full scale deflection of 25 volt. Full scale deflection of galvanometer is one, full scale deflection of ammeter is another thing. Understand the difference. Suppose if we consider a galvanometer alone, full scale deflection means maximum Ig that is passing through the galvanometer. But look at this question, understand the difference here. This is good question. It will teach us the difference between these concepts. A moving coil galvanometer, when shunted with a resistance of 5 ohm, gives a full scale deflection of 250 milliampere. That is after shunting. After shunting with 5 ohm resistance, it is giving a full scale deflection of 250 milliampere. Means the meaning of this is, now this is shunting. So this 250 milliampere is nothing but this current. If it is saying before shunting, or simply if they are saying galvanometer is giving full scale deflection of 10 milliampere, something like that, we can write this Ig as 10 milliampere. But if it gives full scale deflection for 250 milliampere after shunting, when shunted with a resistance, then this current we will have to take as full scale deflection. Okay, so this is 250 milliampere Ig, this is going to be I minus Ig. Clear? There is such a difference. So Ig into G is equal to I minus Ig into S. That is nothing but the shunt resistance. This is one thing which we need to understand. Another thing is, when a resistance of 1050 is connected in series, when a resistance of 1050 ohm connected in series, it gives a full scale deflection of 25 volt. Okay, so this is nothing but, if we connect a galvanometer and if we connect a series resistance, okay, say for example R, then this voltage, that is not the voltage across the galvanometer alone, but this Ig into G plus R is equal to V. Now what we need to find is G. So what we can do, we will just to do the arrangements in this equation, and we will make Ig is there in both the equations. So what we can do, we will make Ig to one side and we will equate the equations. We'll see. So Ig into G is equal to Is minus Ig into S. So here Ig into G plus Ig into S is equal to Is. Ig into G plus S is equal to Is. So here Ig is equal to I into S by G plus S. This is one equation. This side Ig is equal to V by G plus R. This is another equation. So now we will equate both the equations. So this Ig is nothing but the maximum current which can pass through the galvanometer. This current, this will not change for both the cases. Okay, maximum current possible is Ig only. Okay, both the cases. So what we can do, V by G plus R is equal to what we found here actually. Ig is equal to Is by G plus S, right? So this V is given as 25. What is the galvanometer resistance? Galvanometer resistance is given in the question. How much? Okay, galvanometer resistance only we need to find. Okay, what is the resistance which we need to connect in order to make okay, for ammeter shunt resistance is 5 ohm and series resistance is, that is shunt resistance is 5 ohm, series resistance is 1050. Okay, so this is 1050 and current that is coming, main current, this is 250 into 10 raised to minus 3 into 5 divided by G plus 1050. Sorry, this is G plus 5. G plus 5. Right. So 5, this is 5. This is going to be 50. Okay. So G plus 5 is equal to 50 into 10 raised to minus 3 into G plus 1050. Okay, so G plus 5 is equal to okay, 50 into 10 raised to minus 3G plus 50 into 10 raised to minus 3 into 1050. So here G, when we bring to this side, G minus 50 into 10 raised to minus 3 G is equal to 50 into 10 raised to minus 3 into 1050 minus 5. Correct or what? Okay, G minus now 0.05 G is equal to 0.05 into 1050 minus 5. So G, if we take out 1 minus 0.05 is equal to 0.05 into 1050 minus 5. So G is equal to 0.05 into 1050 minus 5 divided by 1 minus 0.05. So simplify this, we will be getting 950 divided by 19, 950 divided by 19, which is nothing but 50 ohm. Okay, D is the answer. Okay, so lot of calculation simplifications are involved in this question, but the major concept which I wanted to discuss is after connecting the shunt or after connecting the series, the maximum deflection current or maximum deflection voltage. In the case of deflection voltage, it will not make much trouble, but in the case of deflection current, should not confuse with the Ig and I.
After connecting the shunt, the maximum deflection current means that is nothing but I, that is main current. Okay, before connecting the shunt, the galvanometer maximum deflection current is nothing but Ig. Okay, so these are some of the problems and concepts of ammeter and voltmeter. Try to take as many questions as possible. Try to practice it. Okay, thank you students. Goodbye, good luck.